A couple of months ago, I did an in-depth performance comparison between several of the Western Digital Blue Series hard disks. And what's interesting there is that Western Digital have 3 drives with the same capacity, slightly different model numbers, and they perform very differently. And this primarily comes down to SMR, or shingled magnetic recording, as 2 of these disks were SMR and 1 is a CMR drive. SMR makes a very large difference to how the drives perform and how much work it has to do to perform its tasks. And though you can usually, though not always, discover on the datasheets which is which, it's often not transparent that the average buyer would have any idea. Also, it's not always reflected in the price, with the CMR drive performing best but often being the cheapest, and I'm going to link that video below. There are also those that always say, don't buy hard disks, buy SSDs, but this misses an important point. There is certainly a steep decline in hard disk sales for the desktop, as NVMe SSDs are for sure the way to go for your primary boot partition and for things that require performance storage such as AAA gaming, video editing, etc. But hard disks do serve an important job for those who want reliable, long-term, low-cost mass storage for applications where multi-gigabit per second I/O performance just isn't important. Analysts Trend Focus reported in 2023 that there were still around 40 million 3.5-inch desktop drives shipped every year, and these are often used for things like data backup, media and document storage. And just because people are buying SSDs for performance use, this doesn't mean that terrible performance is acceptable on spinning disks, and this poor performance is what SMR can give you. So in this video, I'm going to do a full group test of all the main desktop drives that you may find to see not only how SMR and CMR compare, but interestingly, we'll see that each manufacturer's SMR implementation is actually different, and the performance variances are both surprising and large. And even if you already know this and you wouldn't buy an SMR drive, I found the results really interesting, and they tell me a lot about each of the manufacturer's implementations of this technology. And it turns out there are actually very few options to avoid SMR if you're buying the models that are sold as desktop drives, at least below the 8TB range. And this information is also hidden away in datasheets and may not typically be stated as part of the specification on the retail sites, and I really hate this. So let's look at the drives that I've tested, which are all 2TB drives. Starting with Western Digital, we are going to look at 3 WD Blue drive models. There's a 5400 RPM CMR drive, a 5400 RPM SMR drive, and a 7200 RPM SMR drive. Then we look at a very popular desktop drive, which is the Seagate Barracuda. And this is a 7200 RPM SMR unit. And notionally, there is also a Barracuda Pro drive, which is CMR, but I wasn't able to find anywhere where I can actually buy one. And it looks like where they are available, it's really only in the 10TB capacity range or higher. And finally, we look at the Toshiba options. Now, Toshiba sell the P300 drive for this segment, and it comes in the 220 version at 5400 RPM and the 320 version, which is the 7200 RPM version. The 2TB P300 drives from Toshiba are only available in SMR, though it seems that CMR availability exists for very specific capacities, namely the 1 and 3 terabytes, but not for 2, 4 and 6TB models. And given what we're going to learn today in the testing, this is terrible news if you pick up an SMR unit by accident. In this testing, I perform 5 types of tests to see how each disk performs in each case. I do a large file write test where the drive has 10GB files written to it sequentially, taking it from 0 to 99% capacity. And then we do a large file read test to read the files back off the disk. And then a mixed file sequential write test, which copies 10GB of data made up of 5,500 files in 110 folders with a variety of sizes from 16K up to 10 meg. And this test is more intensive on seeks, as the file metadata needs to be maintained during the copy. And then again, a mixed file read test to read all this data back off the drive again. And then finally, I'm going to do a non-sequential write test, which is designed to highlight how the disk manages its SMR zones. And this test rewrites 20% of the mixed size file spread out through each of the 10GB folders across the disk surface. So again, a lot of seek performance, but also this would normally cause impacted SMR zones to be rewritten. So depending on support for things like trim and the size of the zones and how intelligently the drive manages them, that we could see some really big variety in the results. And for those wondering what SMR is, I'm just going to give a really quick refresher. In a normal CMR disk or conventional magnetic recording, files are stored in locations on disk tracks with metadata pointing to where the disk can find them. These tracks are laid out in parallel and they have a small gap between each one to stop write activity on one track disturbing another. Now with SMR, the disk manufacturer tries to make more efficient use of the space by slightly overlapping tracks, and this means that you get higher track density or TPI, which is tracks per inch, And the idea here is you get more density on the same drive, or you can potentially save cost by using that density to reduce disk surface requirements and potentially components required. And it could also allow them to use platters which maybe have a lower bar in terms of usable surface area. Of course, overlapping means that writing to one track impacts a neighboring track, which then has to be rewritten, which then potentially impacts another track, which has to be rewritten, and so forth. So to stop the entire disk needing a rewrite every time, these are placed into zones. So depending on where in the zone an overwrite is performed, some or all of that zone may need to be rewritten. And this can lead to some small write operations ending up needing much larger write operations to get disk consistency back. SMR usually tries to mitigate this by having an area of the disk called a persistent cache, and this is where data is temporarily written to, allowing the zone rewrites to occur during downtime. And I would put downtime in air quotes here because depending on the workload, that downtime may or may not be available and it can vary. So in the final test, I'm actually going to run multiple rewrite tests, giving the disk more and more downtime between writes to see how tolerant each disk is. So for each 2 GB rewritten to a 10 GB test area, I will give it first of all 0 seconds of rest, 60, 180, and then 300 seconds of downtime between each write so that the drive can kind of catch up. Okay, so enough of the technology detail, let's get to the testing. We start with a large file write test, and there are some really interesting things to unpack here straight away. The WD Blue EARZ drive, which is the 5400 RPM CMR drive, performs here very closely to the 7200 SMR drives, including the WD Blue EXPX and the Seagate Barracuda DM008. Now the WD Blue EZ-AZ drive, which is the 5400 RPM drive, is around 20% slower, so there does appear to be a 20% penalty straight out of the gate for SMR, which is then offset by a 20% benefit of going from a 5400 RPM to a 7200 RPM implementation. So for some reason, the Toshiba drives perform far worse. My assumption here from the data is that the WD and Seagate drives write directly to the SMR zones, given that these are sequential writes to basically empty areas of disk. And this is how they get similar performance to the CMR drive. The 20% penalty could be caused by this going through the drive cache, which is DRAM before being written to the service, or just to do with physical layout of the disk, but this is speculation. The performance of the Toshiba drive result implies that they are doing something quite different, potentially writing all data to the persistent cache on the platters prior to writing to the SMR zones. But again, it's hard to know what's in the drive's firmware, but the performance seems to be considerably worse in testing. The P300 72 RPM drive has a slightly improved performance over its 5400 RPM sibling, but they are both far worse than Western Digital and Seagate. So next we run that read test, and the results are far more sensible. All the 7200 RPM drives are clustered at the top of the graph here, peaking at around 240 megabytes per second at the outer edge of the disk, dropping to around 110 at the inner tracks. The 5400 RPM SMR disks are clustered below, peaking out at around 200 megabytes per second and down to around 90 megabytes per second on the inside. The WD Blue CMR disk performs as well as the 7200 SMR disk here, again showing a 20% penalty on the SMR disk for large file reads. The Toshiba P300 220 drive here has a rather strange undulation to its read performance, and again it's unclear why, but it's either down to how the data is managed on the disk, on the platters, or maybe something to do with the read caching. But these tests were run multiple times to catch any variances, and this pattern is repeated exactly in every iteration of the test. In summary, all the drives perform very closely for read performance from all three manufacturers, but the CMR drive seems to get a 20% performance advantage over all the other drives, and the Toshiba SMR drives actually had a very slight advantage here over WD and Seagate, but we're talking 1 or 2%, so it's not large. Now if we look at the average megabytes per second comparison here for full write and read of the drive, we can see again that read performance is largely in line with the spindle speed, with all the 7200 drives performing similarly, and the same for the 5400 units. For write performance, this is also true for the Western Digital and Seagate drives, but the Toshiba drives do very poorly. And this is echoed again in this graph that shows total time to write to and read the entire drive contents, with read time varying from around 3 hours for the 7200 drives and up to 4 hours for the 5400 drives. However, writing to the Western Digital and Seagate drives takes around 3.3 to 3.4 hours, with the 5400 WD SMR disk standing at 4.2 hours. To fill the Toshiba 5400 drive with 10 GB files takes 10.5 hours. So moving on, and the tests actually get more interesting. Now with a mixed write test next. And here we see the best performing drives are the WD Blue EXBX SMR 7200 RPM drive and the Western Digital 5400 RPM CMR drive. Next, the WD 5400 EZAZ SMR drive, and then the Seagate Barracuda, which suffers from worse write performance due to a significant drop off in the last 10% of the capacity of the Seagate drive, again replicated over a number of test runs. The Toshiba drives suffer from terrible performance again here. Again, if I had to speculate, this is a combination of writing data to persistent cache first and then cleaning cache to the main data area, and then combined with the many seeks across the surface that are required for a large number of small files, but the inner workings of the firmware isn't clear to me, so it's just a guess. And if anyone knows for sure or has their own speculative ideas, do shout out in the comments, and you can like and subscribe also while you're down there. So the 7200 RPM Toshiba drive again has a slight performance benefit over the 5400 unit here, but it is a low bar. So for the retest of this data again, the Toshiba drives show more comparable results, with the P300 7200 RPM actually the fastest drive here by a few percentage points. Again, both the Toshiba drives show this strange undulation in their read performance, but with the 5400 RPM drive being more pronounced. What is interesting here, again, is that the Seagate Barracuda has far less smooth performance curve, and it starts to drop off significantly from around 45% of its capacity, and by around 65% capacity, it's only getting around 50% of the performance of the other 7200 RPM drives. And again, the average megabytes per second graph shows that the Western Digital drives fare better, with the Barracuda trailing. The Toshiba drives have good read performance, but the write performance is terrible, with an average of 22 to 26 megabytes per second for the 5400 and 7200 RPM drives respectively. And we can see though that the WD drives take about 3.5 to 4.6 hours to fill up, the Barracuda takes over 8 hours, and the 5400 RPM Toshiba drive takes a massive 25 hours to fill. And now for the real SMR Mageddon test. You see what I did there? Well, what happens when we try to perform non-sequential overwrites of files? And this is a scenario like where you may be updating files on a drive, such as modifying documents or updating configuration files, and this is also relevant for backups. However, depending on how you do this, it may involve a lot of file rewrites. So we're going to start with a 0-second idle time, meaning that as soon as we finish one rewrite operation, we go straight to the next. And we do this for 20% of the data across the entire disk. And what you can expect here is that the persistent cache will receive the modified files, and then the drive will work out which SMR zones need updating, and then will systematically start to copy that zone out to cache, rewrite the modified file, and then write back to the zone. And by giving the disk no idle time, it's going to be doing this while it's also writing new changes to the cache, so performance should start to suffer fairly quickly, and then depending on the size of that persistent cache, it's going to eventually fill up, and at this point the disk has to write data directly to the SMR zones via a read out to cache, rewrite, and then write operation. So in short, I would expect port performance to start to drop until the cache is filled, and then it'll drop quickly to the actual write performance of the disk if the data was not cached. And this is going to reveal how SMR really performs on the drive. During this test, we will see that the CMR drive performs a more linear and predictable manner. In short, this is why you should buy a CMR drive. The WD-SMR drives suffer a degradation in performance as the persistent cache fills, and from the data it looks like this cache is probably in the region of around 15% of the disk size. The performance then collapses to around 20% speed at 20% capacity, and then it slowly deteriorates all the way down to 10 to 15% performance of the CMR drive over the rest of the disk. Now this sounds bad, but these are actually the best performing SMR drives in the test by some margin. The Seagate drive initially has a similar degradation as the WD-5400 SMR drive, but it appears to run out of cache at only around 2%, suggesting the persistent cache is far smaller than on the WD drives. It then hits almost zero throughput, recovering at 13% capacity to around half the performance of the WD drives. This slowly converges over the WD drive performance, finishing with around the same performance, but still only just over 10% that of the CMR drive. Now the Toshiba drives perform here similarly to the Barracuda, and this isn't a good thing, with the 5400 Toshiba drive eventually at less than 10% of the performance of the Western Digital CMR drive in the test. So next we're going to start to provide some idle time between tests to see how this affects the results, because in fairness, it's not going to be common to write 20% of the drive in one go. And we see here that firstly, the CMR drive doesn't seem to care. You will get roughly the same performance out of it, however much idle time there is or isn't. We do see the larger persistent cache size on the WD drives helps them the most if a little idle time is given, with the worst of the performance degradation starting at 30% capacity rather than 20% on the 7200 RPM drive, but with the 5400 RPM drive benefiting less. The Seagate and Toshiba drives seem to not benefit from this in any notable way, probably due to much smaller persistent cache that they have. And as we extend the idle time to 3 minutes between tests, we see a real change in performance across all the drives. First of all, the WD SMR drives now compare better to the CMR drive. And this is because the data is actually being written to the persistent cache, which is on the best performing part of the disk at the outside edge, where the CMR drive is writing directly to the locations across the platters. But this is a bit misleading, however, as the SMR drive continues to write data for some time after the write test is finished, as the cache cleaning process of rewriting the SMR zones occurs. It does mean for disks that are not busy and where small random writes occur, you could get slightly better performance on an SMR disk than CMR, but the improvement is slight and really it's smoke and mirrors. The Toshiba drives continue to perform the worst, and the Seagate Barracuda still has some odd behavior when its persistent cache is filled, but its recovery at 12% is far more convincing. And finally, we give the drives 5 minutes of R&R between tests, and we see similar but further improved results, especially for the Toshiba drives, though due to write performance, the Toshiba 5400 RPM drive still does eventually run out of performance at 90% capacity, and it starts to drop off. Looking at the time to rewrite 20% of the drive with less than 3 minutes of idle time between 2GB writes, all the SMR drives do very badly compared to the CMR drive. But this is more pronounced on the Seagate Barracuda, and the Toshiba drives suffer the most. Even with 5 minutes of idle time, the Toshiba drives take twice as long as the 5400 CMR drive, and this is after writing just 2GB, and it doesn't even take into account the 5 minutes of idle time. Even without the idle, the Toshiba drives average around 6.5% of the write performance of the CMR drives. From a megabytes per second standpoint, the CMR drive gets a small boost with a little idle time, and this may be to do with write caching on the drive, but then it delivers consistently at around 100 megabytes per second. The WD SMR drives suffer a large penalty, but they reach their potential when given at least 3 minutes of idle to perform cache cleaning. The Barracuda and Toshiba drives results speak for themselves. So some really interesting results and insights into what's going on inside the firmware and on the physical layout of the drives. And a quick look at the pricing, I found that these drives across multiple sellers in the US and UK, and it shows that the price of the CMR drive is often cheaper than other options. Seagate do currently have good pricing on the Barracuda, which could definitely tempt people, at least in the UK, but overall there isn't really a premium to buy the one available CMR drive, but prices change of course. Okay, firstly, thank you for bearing with me through all the data. But before I give you my conclusions, if you like data visualized and analyzed to reveal what's really happening inside technology and products, then please do like and subscribe. I have more of this coming, and given what we learned here about desktop drives, I'm going to be comparing their performance against other options, including the surveillance drives, so do stay tuned for that. Also, please share with any other data nuts or hoarders who might care more about than just NVMe performance, and I will also be doing some performance analysis on that soon. You can also support me if you'd like to at Buy Me a Coffee, link below, by buying me a caffeinated beverage. I'm still in the early stages of growing this channel, and your support and caffeine infusions are so appreciated. Okay, conclusions. And well, SMR drives certainly seem to perform badly in many use cases. We know this, but I think now we can see how and when they do badly and why. And also which implementations perform worse. And I personally would never buy an SMR drive other than to torture it and give you this kind of test data. So if you do want to buy a desktop drive, I suggest to always pick out a CMR unit. I'm going to put an affiliate link below to the WD Blue CMR drive, but I would not 100% trust that Amazon links it always to the same model number, so make sure you check. But even between the SMR drives, it looks like Western Digital just do a better job with their implementation. They appear to use a larger persistent cache, meaning a performance impact is less likely, but it's also going to be less severe. Barracuda drive from Seagate has some variable performance with some odd drop-offs, but it seems to have relatively small persistent cache, and overall its performance in testing was worse. The Toshiba implementation is what puzzles me the most, and they appear to use a small persistent cache, but also their firmware seems to perform badly with writes, even when the drive is empty. I didn't include the file delete results here as they were all over the place and they're very hard to graph out, but in summary, the Toshiba drives seem to perform extremely poorly with deletes also, and I think this is likely due to the fact that those drives do not even seem to support trim. Testing the TOS drives took a lot of time, because even once a test finished and the drive was emptied and the partition deleted and recreated, the drives were often thrashing for hours sorting themselves out. In the end, I just had to leave the Toshiba drives to idle for at least 8 hours between tests, just to give them a fair crack at the next test. I would not touch a Toshiba SMR drive at all for any use case, and they're often more expensive. So, thank you for watching to the end, and I hope you found interesting information here that you have not seen elsewhere, and I will see you in the next.